Okay, welcome back. In this video, we're gonna try to prove that f of x, which is equal to x over the square root of 1 plus x, is injective. First note that the domain of definition of our function is, or our function is defined when 1 plus x is strictly bigger than 0. This means that x is bigger than -1, and therefore the domain is -1 plus infinity. So our function is defined here. And to prove that f is injective, we can prove that it is increasing. Okay, remember that when the function is increasing, it can't have two different elements that have the same image. It can't be. Okay, remember that to prove that f is injective, we can prove the following. We take any two elements, a and b, in our domain, and we prove that if f of a is equal to f of b, then we have to prove that a is b. Okay, we can use this one here, and we can use algebra to prove it, or we can use just the derivative, or we can prove that f prime of x is bigger than 0. So which one is easier is our tool to deal with this problem. So here to find the derivative, so we're gonna differentiate f over g. So here we have the derivative of x is 1 times the square root of 1 plus x minus x times the derivative of this one here, which is 1 over 2 the square root of 1 plus x, everything over the square root of 1 plus x squared. So here this is just 1 plus x. So we can simplify, and we can see that 2 times the square root of 1 plus x minus x over 2 1 plus x times 1 plus x to 1/2, and this is squared. So here we're gonna have 2 plus 2x minus x over 2 times 1 plus x to 2 over 3, and this will give me x plus 2 over 2 times 1 plus x to the power 3 over 2. So now we need to prove that this one is bigger than 0. Okay, if we can prove this one, that means our function is increasing and therefore it's injective. Okay, so now we're gonna prove this one here. So the key idea here is using the domain. So we have x is bigger than -1, adding 2 to both sides, we have x plus 2 is bigger than 1. And also we have 1 over 2 times 1 plus x to 3 over 2 is bigger than 0. Okay, because we have 1 over 1 plus x is bigger than 0, so we can take this the power 3 over 2 and multiply by 2, and we see that we have the result. Therefore we have x plus 2 over 2 times 1 plus x to the power 3 over 2 is bigger than 0. That means f prime of x is bigger than 0. This means that f is increasing. Okay, so my function is increasing and therefore it's injective. Okay, so this is one way of proving that f is injective. We can use the definition. We can use this one here, and we prove the result. Okay, we can do that if we want, but here we're gonna have to prove that a plus b plus ab is not 0. Okay, this one is always different from 0, except when a is equal to b equal to 0. Okay, so once we get there, we're gonna have to factor out, and we're gonna have a minus b times a plus b plus ab is 0, and this one is never 0. Okay, so we assume a is equal to different from 0, b different from 0, and therefore we have only a minus b equals 0, and therefore a is b. And this proves that f is injective. Okay, so this is if we want to use this one here, but I think proving that f is increasing is quicker. Okay, what do you think? Thank you very much. We're going to come back to this one and find the inverse function.